All right, let's talk about a word we use all the time, acceleration. We all think we know what it means, right? But the real science behind it, well, there's a little more to it than you might think. Let's dive in.
Seriously, just for a second, what pops into your head? For most of us, it's probably the gas pedal in a car or twisting the throttle on a scooter. You know, that feeling of going faster.
And yeah, you're not wrong. But thinking it's only about speeding up is just scratching the surface. We're about to go way beyond the pedal to see what's really going on.
Yeah, exactly. Stomping on the gas, feeling that push back into your seat, that is absolutely acceleration. No doubt about it. But if that's where we stop, we miss out on how cool this concept really is.
Because here it is, the official scientific definition. And this is where things get interesting. Acceleration is the rate of change of velocity. And here's the key. In physics, velocity isn't just speed. It's speed and direction. So get this, if an object's speed or its direction changes, it's accelerating.
So how do we actually put a number on this change? Well, like with a lot of stuff in physics, there's a surprisingly simple formula that helps us measure it perfectly.
It really just boils down to 3 easy steps. First, you take whatever the final velocity is, then you subtract the velocity you started with. That tells you the total change. And finally, you just divide that change by how long it took. That's it.
And when you do that math, you end up with this unit that looks kind of weird at first, meters per second squared. But what does that little squared even mean? It's simpler than it looks. It just means meters per second. It's telling you how much your velocity is changing every single second that goes by.
Okay, enough with the theory, right? Let's make this feel real. We're going to put that formula into action with a fun little story, a bit of a friendly roadside competition.
So picture this. You're just out for a nice drive, cruising along in your trusty Alto. You're moving at a steady 50 kilometers per hour. Everything's pretty chill. But then, bam! Out of nowhere, a Bugatti just rolls up next to you. The driver gives you that look. You know the one. The challenge has been made. And your legendary Alto, it never backs down. So you floor it. You hit the gas hard. And in just 10 seconds, you go from that calm 50 kilometers per hour all the way up to an insane 400 kilometers per hour. That is a huge change in velocity.
Okay, let's run the numbers. Your velocity changed by 350 kilometers per hour, right? And it took you 10 seconds. So you divide 350 by 10 and you get 35. That means your acceleration was 35 kilometers per hour per second. Every second, your speed was climbing by another 35 kilometers per hour. That's what we're measuring.
So, we've seen what happens when you hit the gas. But what about the opposite? What happens when you hit the brakes? It's time to really blow up our old definition of acceleration.
Let's rewind a bit, back to before that Bugatti showed up. You were just cruising, holding a constant 50 kilometers per hour. Your speed wasn't changing at all. So here's the question. Were you accelerating then?
Nope, exactly. If there's no change, there's no acceleration. Your final velocity is 50, your initial velocity was 50. 50 minus 50 is 0. So it doesn't matter how fast you're going, if your velocity is constant, your acceleration is 0, period.
Now think about the forces involved. To speed up, the engine applies a force that pushes you forward, in the same direction you're already going. But when you slam on the brakes, a force is applied in the opposite direction. It's literally fighting against your motion to slow you down.
Which brings us to the big one. If acceleration is any change in velocity, and hitting the brakes definitely changes your velocity, does that mean slowing down is actually a form of acceleration?
And the answer is yes, absolutely 100%. In physics, we call it negative acceleration. Your velocity is still changing, isn't it? It's just decreasing instead of increasing. It's really just the other side of the very same coin.
You might even hear an older term for this, retardation. Nowadays, we pretty much just call it negative acceleration or deceleration. It's just what's happening anytime an object is slowing down, anytime its final velocity is less than its initial velocity.
So let's step back for a second and just look at the complete picture we've built here. It's not just about speeding up anymore. It's about any and every change. And this table just lays it out perfectly. You've got 3 states. Positive acceleration, that's when your velocity is going up, you're hitting the gas. Zero acceleration, your velocity is constant, you're just cruising on the highway. And negative acceleration, your velocity is going down, you're hitting the brakes. Simple as that. So I'll leave you with one last little puzzle to chew on.
Remember how we said velocity is both speed and direction? Okay, so imagine a car going around a corner. It keeps its speed exactly the same. The speedometer doesn't budge. But is it accelerating? I mean, its speed isn't changing, but its direction is. So what do you think that means? Think about it.